Okay, so we're discussing triangles today. A prerequisite topic for triangles is lines and angles, which I'm assuming that because you guys have covered your matriculation, FSC, O levels, and A levels syllabi before taking these classes, so I'm assuming that lines and angles are pretty much clear to all of you. But still, we can go through specific problems if anyone of you will have those problems. So we're starting off with triangles. The basic discussion that is important for triangles is that you should know all of the angles in a triangle are equal to 180 degrees. This is the sum of all the angles, okay? So whether it's a right angle triangle, this is what a right angle triangle is, where one of the angles is 90 degrees. It can have any orientation possible, all right? So it's not important that right angle triangle is always going to be upright like this. It can have any orientation. It's up to the diagram, all right? And then all of the angles, they're supposed to be equal to 180 degrees. This is important. You see in the first figure, it's 90, 30, and 60, 180, 90, 45, and 45, 180, 60, 60, 60, 180 degrees. These are the three types of triangles. This one is called a right angle triangle, all right? This one is called an isosceles triangle. Why is it an isosceles triangle? Because it has two same angles, right? And one different angle. This one has three same angles. This is called an equilateral triangle. So you guys should be able to classify triangles into these three types. Now, if you move on to this example, it says that figure below, what is the value of x? For this is the value of x over here, okay? So for this value of x, we need to first of all get this angle over here, that is b. This is 90 degrees, right? Straight up. We need to find out this angle, angle C. But for angle C, it is important for us to know the vertically opposite angle of angle C as well, okay? So I hope you guys know these properties as well. There are like different properties for angles. For example, an angle can be vertically opposite. Let me just recall these properties. I'm sure you guys have already studied these as well, but vertically opposite angles are like this. If this is one angle, angle A, so angle opposite to it, angle B is also going to be equal. A and B will be same. These are called vertically opposite angles, okay? Similarly, if I raise it off, the other type of angles are alternative angles, okay? What are alternative angles? Alternative angles are like this. If you have a parallel line, two parallel lines, and you've got like angles over here. So if this is one angle, this is gonna be the alternative angle of it, okay? So yeah, no, not this one, okay? This is also same, this is also same. You see these two are vertically opposite. If I write A and A, they're vertically opposite. This one and this one, B and B, they're alternative angles here. Yeah, we need two lines, two intersecting lines as well. And then for corresponding angles, the third type is corresponding angles. Corresponding angles are these ones. If you have like C over here, this is angle C. Let me use different colors so it's more easy for you guys to understand. So I'm coloring corresponding angles in red. All right. So the red angles are what? They are called corresponding angles. I'm writing C on top of these angles, okay? Then the angles I'm coloring green, these angles are alternative angles. I'm writing A on top of these. So alternative angles are green. Then the remaining ones, the blue ones, they're called vertically opposite angles. I'm writing V. Now, I hope this is pretty much clear to you guys. So all of these angles, any angles following these properties are going to be equal. We're using the same concept in this example here as well. If this is 35 degrees, this is 120 degrees. So you add them both minus, subtract them from 180, you're gonna get 25 degrees over here. So C is 25 degrees. So automatically this will also be 25 degrees. Now, if this is 25 degrees and this is 90 degrees, this entire angle is 180 degrees. So what you're going to do is you're going to subtract 180 minus 90 minus 25, and you will get what? You'll get 65 degrees this here. All right, guys, I hope this is clear. Similarly, if you look at example number 2 as well, you've got two angles. The third one can be easily figured out by using the same concept. Add them both, subtract from 180, you're going to get this one, which is 60 degrees. If this is 60 degrees, guys, look at this. This is an exterior angle A over here. But this exterior angle and this interior angle, they're both on a straight line. If the interior angle is 60 degrees, so straight line has what? It is a total of 180 degrees. So 180 minus 60 is going to give you 120 degrees. The remaining angle outside this line would be 120. So the sum of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles. So yeah, this is also true. If this is an exterior angle, right? So the opposite interior angle, 75 and 45, once you add them, they're also going to make up 120 degree. This is the rule. So if you don't, let's say if a question is a bit challenging and you cannot figure out the exterior angle just through this direct approach, you guys can remember this method as well, that two opposite angles of an exterior angle. So if you look at the interior angles opposite to that particular exterior angle that you're talking about, the sum of those two interior angles is going to make up the value of that angle as well, value of that exterior angle, sorry. Okay. So if you see, one of the ways was that we figured out 60 degrees. If we hadn't, for example, you could have simply added 45 and 75 and you would have gotten 120 degrees. All right. All right. Now, example number 3. Which of the following statements concerning the length of side YZ is true? This is side YZ. Okay. One of the sides is 8, one of the sides is 10. So what should be YZ? Guys, there's a rule before this that you should need to know, that the longest side is opposite to the largest angle always. The shortest side is opposite to the smallest angle. Sides with same length are opposite angles with the same measure. So if let's say this is 10, 10 is opposite to 71, 8 is opposite to 49. We can figure out this angle, right? 180 minus 71 minus 49 is going to give you 60 degrees. So this is 60 degrees. Now we know that 60 is not the smallest angle. So 8 has to be the smallest side. Why? Because it's opposite to the smallest angle, that's 49. And 71 is the biggest angle. So 10 has to be the biggest side as well. Now, this length of x, this YZ is going to be in between 8 and 10. So it'll be more than 8, it'll be less than 10. Hence, this condition is true. So we're going to use this concept of corresponding lengths and angles, and this is how we get the answer. Is this clear to all of you? Okay, most of these concepts are about acute, obtuse angles, right triangles, all right? So if you look at this formula, a square e plus b square equals c square, considering that c is the hypotenuse, guys, this is basically Pythagoras theorem that we're talking about. Hypotenuse square equals base square plus perpendicular square. So this is equal in a right angle triangle. This is the Pythagoras theorem that falls true. A square plus b square will be less than c square if angle c is an obtuse triangle like this. Let's say this is A, this is B, and this is C. So if angle C is an obtuse angle greater than 90, this second condition will be true. If it is an acute angle like this, maybe this is C, so third condition, that A square plus B square will be greater than C square. Just remember this theory. For the initial set of questions, you guys can have this theory in front of you. You guys can refer to these notes just so you can have an idea as to what you're supposed to apply, okay? Look at this. Which of the following cannot be the lengths of the sides of a right triangle? Now, what cannot be the sides of right? You need to apply this. A square plus B square equals C square. Now, whatever option falls true for this one, that will not be the correct answer, because we're looking at any set of lengths that cannot be the lengths of right angle triangle. So A is 3, 4, 5, it's always a right angle triangle. 3 square plus 4 square equals 5 square, 25 plus square banega. So A is a right triangle. Then 1 square, you see they've done 1 square plus 1 square is equal to root of 2 square. Root of 2 square भी क्या बनेगा? 2 बन जाएगा. This is also true. अच्छा, root of 3 square plus root of 7 square, 4 square क्या बना? 3 plus 4 is equal to 7. It's not equal to 5. So this is the correct answer option because this is not a right angle triangle. इसमें क्या हो रहा है? A square plus B square is not equal to C square. This is exactly the answer option that we were looking for. Is this clear to all of you? Guys, if you get stuck anywhere, please do ask. Don't wait for the lesson to be over, okay? Just stop me there and then and ask questions. It's very important that you guys have a clear understanding of these questions here. Okay. You see, this is how you can always divide triangles. 30, 60, 90. You can divide them into two halves. You can always figure out like the shapes like this. Okay. In a 30, 60, 90 right triangle, the sides x, x root of 3 and 2x. Now you need to know that this is how you can work around a 90, 30 and 60 triangle. That if the side opposite to 30 is x, side opposite 90 is 2x, and side opposite to 60 is x root of 3. Similarly, if you apply these concepts to example number 6, what is the area of a square whose diagonal is 10? Now, you have a square and the diagonal is 10 over here. So what we can do is now look at the type of angle triangle that you have, 45, 45, and 90. Let me show this to you as well. I think the concept, yeah, 45, 45, 90 right triangle. This is the first one. Look at key fact J8. A 45, 45, 90 triangle will always have x, x, and x root of 2. All right, first thing. Then a 30, 60, 90 right triangle will have x, 2x, and x root of 3. You guys need to know these two types of right triangles. Now, if you divide a square with a diagonal of 10, you get a 45, 45, 90 right triangle. Now you look at J8, this side would be what? If this is x and this is x, what did we just study? That your third side is going to be equal to x root of 2. So x root of 2 equals 10, where x equals 10 over root of 2. You see, this is how you get 50. You get a value for x. So just remember this concept. Just remember the two types of right triangles, 90, 45, 45, and 90, 30, and 60. That being said, we are... Just a second. Okay, now we're moving on to the concept of similar triangles. Okay, what is a similar triangle? A similar triangle is the one that changes with a similar ratio. All right. They cannot, I mean, they can be of different sizes, but the ratios are the same. Okay. For example, these two triangles, both of these triangles are similar. Why? Because they look the same, but the ratios by which their sizes change, the ratios are same. Okay. You need to have these two conditions satisfied for similar triangles. Number one, three angles in the first triangle are congruent to the three angles in the second triangle, right? For example, angle A must correspond to one particular angle in the other triangle, right? Um, if A equals D, A and D are congruent, B and E are congruent, C and F are congruent. You see, angles have to be congruent. क्या आप ये कह सको A corresponds to D, C corresponds to F, B corresponds to E. All of these angles are congruent. Number two, the lengths of the corresponding sides are in proportion. For example, if this is 2, so this has to be 4. If this is 3, so this has to be 6. If this is maybe 1, so this has to be 2. Factor of 2. Now, this factor of 2 has been applied to all of these three lengths. There has to be a similar proportion that applies to all of the individual lengths. Only then a triangle will be similar. All right, just remember these two properties. Example number 11. Look at this. What is BC? This is the length that we are finding. All right, this. So now you've got these two triangles. Let's try to draw them in a similar way. If you've got D, C, and E, so the other triangle is gonna have what? It's gonna have A over here. It's gonna have C over here. It's gonna have B over here. AB is 4 over here. DE is 3. Then CD is 4. B and C is what we are finding. ठीक है, तो हमें we know this information. Now the question says, what is BC? Now you need to understand that ECD, this is E, C, and D, is congruent to ACB, A, C, and B. Yani A corresponds to E, right? A will be equal to E. Equal नहीं हम कह रहे क्योंकि corresponding congruent है, values different होंगी. D corresponds to B or C corresponds to C. Okay. So now you can use proportions, right? अगर हम lengths के proportions use करें कि DE जो है, which is 3, it is equal to it is equal to AB, right? Over here. जैसा यहाँ हमने proportion use किया हुआ है. DE over AB हम या equal to AB कर देते हैं, ठीक है? या over AB कर दें because they both are proportional, right? So let's just write AB and then DC, which is 4, should be equal to BC, which is what we're finding. So DE क्या था यहाँ पे? DE was 3. So we're going to write 3 in place of DE. Then AB was 4. We're going to write 4. Then DC was what? DC was 4 and BC was what we were finding. So 3x equals 16. 16 upon 3, ये आ गया हमारे पास length of BC. So you're going to use direct proportions, guys. Just remember, we've studied ratios and proportions. This topic is very much similar to that. So just keep these things in mind while you're solving these questions. Okay, now we're moving on to the exercise. I think you guys can start working on these questions now. For everyone, you have like 30 minutes to quickly solve this assignment. Share this in the group as soon as you're done.